In this video, I'm going to cover a popular trading strategy from TradingLab YouTube channel, which combines the Bollinger Band and the RSI trading strategy. What I am going to do is to show you how to code up this strategy in Python, and then I'm going to show you the returns with the default values suggested by TradingLab, and then I'm going to finally show you my own twist on the strategy that leads to a win rate of about 71%. So follow along in order to understand how to code up this popular strategy in Python, and then to understand how to improve the strategy to get a 70% plus win rate. So what does this strategy do? If you follow this strategy or this video from TradingLab, it suggests that you take a long trade when two conditions are satisfied. When you reach the lower Bollinger Band, like here, and the RSI value is below 25. And the TradingLab video also suggests that you change the conditions in order to make the length of the Bollinger Band equal to, or the length of the moving average equal to 30 instead of the original sort of default setting of the Bollinger Band. So this is in essence the strategy in order to take long trades, and we are only going to take long trades and no short trades. So with that being said, let's understand a little bit about Bollinger Bands, and then I'll come to RSI. So let's look at this execution of the strategy, which is backtested on Bitcoin data that we are using. So let's see what happened in this first trade here, where these are the candlesticks, and the black and the blue lines are the Bollinger Bands. So this is the first time that the price touches the lower Bollinger Band, and we are going to take a trade. And then this is where we sort of exit the trade in a profit because it has hit our take profit. And then we take a second trade, which is here, where again the price touches the lower Bollinger Band, but this time it hits our stop loss and we exit the trade at a loss, and so on and so forth. So this is the basic setup. And in each of these cases, the RSI value is below 25, which is sort of separately plotted. So let's go to the code and understand how to execute the strategy, which is spelled out in TradingLab's video. So in order to execute this strategy, we'll have to take two steps. We'll have to calculate the Bollinger Bands, and then we'll have to calculate the RSI. And then we will have to apply these two sort of rules that the video asks for in order to enter these trades. So I have made a previous video about how to calculate Bollinger Bands, and if you are interested, I will link to the video in the description below and in the video itself. But just as a brief recap, we set a window of the Bollinger Band. So typically this window is set to 20, which is what we will do now, and then we will follow sort of the advice from TradingLab and set it to 30 separately below in the notebook. So we first calculate the simple moving average based on the closing values, and this we do we shift the value by 1 because we only want to consider values till the last candle when we want to calculate the Bollinger Band for the current candle, so that we don't sort of leak data from the current candle. And this is a recurring theme in many of my videos if you follow the other strategies that I discuss. And then I similarly calculate the rolling standard deviation. So the rolling function in Pandas allows you to calculate any rolling values, and then you can sort of say what sort of rolling values you want. In the first case, we want the rolling mean, and the second case, we want the rolling standard deviation. And then we have a multiplier, which is standard set to 2. And so we calculate the upper Bollinger Band as the simple moving average, and multiplier multiplied by the standard deviation. And this is sort of an upper range on where the price action should be, and when the price action touches the upper Bollinger, it is thought to be overbought and we can expect the price to drop. So there are multiple examples in this here. So it touches the upper sort of Bollinger Band, and so it's overbought and the price drops here. And on the other end, we also see that if it touches the lower Bollinger Band, like here, the price, it's sort of oversold and it sort of goes up from here. Okay, so now we are done with the calculation of the Bollinger Bands. Let's come to the calculation of the RSI, which is a little more involved. The RSI calculation involves one sort of parameter, which is the window, typically set to 14. So again, we take the shift the values by 1 to exclude the current candle, and then we calculate the daily price changes. So this is in this diff, which calculates the difference between this candle and the previous candle. And so maybe it is useful to look at the definition of RSI. So this is Investopedia. We look up the definition of RSI here, and the RSI definition is basically 100 minus 100 by 1 by average gain by average loss. So this is basically saying on the days that we gained in the last 14 days, what was the average gain and what was the average loss in the days that we lost. And then you should have do this calculation on the average gain and loss. So if the average gain was 1% and the average loss was 0.8%, this is how the RSI calculation looks like. So now to do this in pandas, we have to calculate the average gain and the loss. So the average gain here is simply, again, we do this on a rolling basis. So the average gain here is simply the rolling mean of the gains. And the gain is where, where the delta is larger than 0. So delta was our delta between current candle close and the previous candle close, and the gain is when the delta is equal to 0 or greater than 0. Otherwise we set the value to 0, and same for the loss. And so we set the loss values are less than 0, but we want a positive sort of average loss so that we can do this RS calculation. So the average gain again is rolling. So rolling mean of the gain values, and the average loss is the rolling mean of these loss values. And then our relative strength is sort of average gain by loss, which is simply sort of this part of the calculation. And then we finally have to do this other, like the 100 minus 100 by 1 plus RS calculation. So this is what happens here. We calculate the RSI by making this calculation. And then because we looked at the previous windows, the first value will be 0 so that we don't have an NA. We filled it up with 50. So that's the average. So that's the RSI calculation. So we have two steps. We have the Bollinger Bands and we have the RSI. For sanity check, we plotted the RSI values. It should lie between 0 and 100, which we see as the sanity check passes. So now we apply the Bollinger RSI strategy on our backtesting library. There is a separate video that I have on how to execute or how to code up the backtesting library. If you want to look up that video, that describes in detail how the backtesting library works, but I will not go into great detail on the library itself. What I will tell you is how to execute the Bollinger RSI strategy. So all of my strategies derive from the base strategy, and they basically say what is an entry signal. So if the entry signal is satisfied, we buy. So as an example, I think this is a random strategy, the simplest possible strategy, where the entry signal says, is the random number equal to 1? Get a random number. If the random number is equal to 1, then buy if we have enough cash. And we typically have enough cash to buy 1 Bitcoin, so we can buy 1 Bitcoin at a time. So in this case, the Bollinger, so the Bollinger signal is true if the current candle, the low of the current candle is lower than the lower end of the Bollinger Band. So this basically says that, for example, it is satisfied somewhere here, where the low of a candle here is lower than the lower Bollinger Band, which is this black line. So whenever the low of the candle is below this black line, this condition is satisfied. So this is the Bollinger signal. And this is the signal of the RSI, which was suggested by the video here, which says that the RSI should be less than 25. So something like, yeah, so the RSI value goes then less than 25. This is the second condition that is suggested by the TradingLab video. And when those two conditions are satisfied, we buy a stock if we have enough cash. And then our exit conditions are always the same. We have a profit and a loss percentage of 1%. So we exit the trade if we hit those profit loss percentages. And we set that to 1%. Okay. So that's the strategy. For illustrative purposes, we see what this does in this really small sort of window here. Again, we shouldn't read too much into the actual data here, but it's possible to sort of backtest the strategy here, and you can see the trades that it takes, and it probably does not very good. That's fine, and we also did not use the default value suggested by TradingLab. So we'll test a separate version of this strategy before we go on to the next steps. So the other version of the strategy we built is sort of the variable Bollinger Bands. So in the first case, so let me explain the difference between these two strategies. In the Bollinger RSI strategy, which is the original strategy from the TradingLab, we use a take profit of 1% and a stop loss of 1%. In the variable strategy, we basically use the Bollinger Bands to calculate the stop loss and the take profit. So we are saying that when we take the trade here, we're going to take the difference between the SMA and the Bollinger Bands as the take profit value. So if the width of the Bollinger Band is large, we're going to set a large take profit and we're going to set a large stop loss, and they will be equidistant from each other. That's the difference between the so we calculate the percentage of profit and loss using this value, and then we set that in our sort of buy order. Okay, so that's the difference between these two sort of flavors of this strategy. And let's see where we executed it. Okay, so this is the variable stop loss. And again, we're not doing very well in this particular small example, but we will ignore it for now. And then we will look at what happens when we have large data and when we set the parameters correctly. So our goal, which is the twist that we add to the strategy, will be to optimize the strategy. But before we go there, let's understand what happens if we set up the default values by TradingLab. So just to give you how the Python code executes, we define this optimization function, which takes the data frame and all of the values that we can optimize over. In this case, we can optimize the Bollinger window, the multiplier of the Bollinger Bands, the RSI window, and the profit and the stop loss percentages. And if we add this verbose value, so if the verbose is by default set to false, if the verbose is set to true, it gives us shows us the stats from this strategy. It prints out the stats from this strategy, so if we call this optimization function, so we want this optimization function to do two things. First, we call it with a certain value. It will show us what the result of this strategy is. But its return value also contains the actual sort of return percentage. So if we call the optimization function with a large number of different parameters, and we can optimize over those parameter space. So that's the idea. So we call this with TradingLab's default values. And what happens here? For our instrument, and again, I'm not suggesting that this happens for all instruments. For different instruments, for stocks, we might have a better result. But for Bitcoin 5-minute data, we saw that it does not perform very well. It goes to minus 0.8%, which is less than the buy and hold return of 0.4%. So then we do the optimization. We optimize over the profit percentage, stop loss percentages, the Bollinger window, the RSI window, and the multiplier. So we run 200 steps of optimization, which give us a different set of best parameters. So unlike what TradingLab's suggests as 30 as the Bollinger window, this tells us 15 as the Bollinger window, and it suggests an RSI window of 20. So the typical RSI window is 14, but we're going to change that to 20 based on the optimization results. And then it suggests a multiplier of 2.5, whereas the typical multiplier is 2.0 if you look up the so the standard deviation is 2.0 in the case of TradingLab, and that is the default value in TradingView software. So now we take the same data frame of 2000 data points, and we're going to use the suggestions from our optimization. What happens when we do that? We observe that we are beating the buy and hold by a large amount. So our return is about 4%, buy and hold is 0.4%. So like 10x returns compared to the buy and hold, and we get a win rate of about 71% compared to a 45% win rate when we use the default values. So basically we take TradingLab's strategy, which is a great strategy, combines Bollinger Bands with the RSI to give us good entry points. We use our optimizer in order to sort of add upon the strategy and construct the best strategy for our data set and our sort of instrument in this particular regime, and we are able to get about 70% win rate based on our strategy. Hope you enjoyed this video. Please like and subscribe if you want to see more executions of trading strategies in Python. Thank you.